Hello dear learners, today in this video I am going to solve the question number 7, which is very easy question. We have solved this type of question in class 8. Find the smallest positive integer, multiplication by which makes the following number a perfect square. That means we are given some numbers. Now we have to find such a positive integer by which if we multiply the number it became a perfect square. That means to make this number a perfect square, what number should be multiplied with this number? We have to find out that, no? So for that, in this type of question we have to factorize the number first. So how will you proceed? First of all, we have to factorize 3675. So factorize it. So which digit divide the number? 2 does not divide, so let's see with 5. 3 plus 6 9, 9 plus 7 16, 16 plus 5 21. That means 21 is divisible by 3, so this number is also divisible by 3. So divide by 3. 3 divides 3 one time, 3 divides 6 2 time, 3 divides 7 2 time, and carry 1 15 5 time, no? You can see again 1 plus 2 3, 3 plus 2 5, 5 plus 5 10. So it does not divide, so we have to see with 5. Since the unit place is 5, so the number is divisible by 5, and so divide by 5. 5 divide 12 2 time, carry 2. 5 divide 22 4 time, carry 2. 5 divide 5 5 time, no? 25. Again this divisible by 5. 5 divide 24 5 time, carry 4. Oh sorry, this 5. 5 divide 45. Sorry, 5 divide 24 4 time, no? It is 4 time, and remaining is 4 and 5 49. 5 divide 49 49 time, 45 49 7 9 time. Now 7 divide 49 7 time, so we cannot divide anymore, so therefore 3675 can be written as 3 into 5 into 5 into 7 into 7, no? Now see what we have to find. We have to find a number by which we have to multiply this number to make a perfect square. So first of all, in this sum you have to pair the factors, all the factors. So this is one pair, this is one pair, no? So which factor does not have any pair? The fact it is 3, no? Since 3 does not have any pair, so if we make a pair with of 3, then it will completely a perfect square number, no? If we multiply a 3 here, then 3 will also be a pair, and 5 has pair, 7 has pair. When all the factors became pair, then that number is a perfect square number, no? Because 3675 here, if we there are 3 into 5 into 5 5 into 7 into 7, no? So from this 5 1 5 come out, from this 7 1 7 come out, but this 3 is alone, it will remain inside. But if somehow there would be 1 3, then this would be a perfect square number, but this 3 has no pair, so we have to multiply the number by 3 to make it perfect square. So since 3 does not have any pair, 3 does not have any pair, therefore 3675 should be multiplied by 3 to make it a perfect square, no? If we multiply the number, then it will become a perfect square number, no? So other sum you will do in the same way, very easy sum. So save 8 number question. In 8 number question, I am not writing the question here. In this question, we have to find out by which number we have to multiply the following numbers to make it a cubic number. So for cubic number, we have to unite the factor with three factors. No, if we can find a pair of group of 3 factors, then it will become a cubic number. Let's see one question. Suppose one number is given 7623. So first of all, factorize it. 2 does not divide. Let's see it by 3. 7 plus 6 13, 13 plus 2 15, 15 plus 18. So 3 divides. 3 2 time, 5 time, 4 time, 1 time. No, again let's see. 2 plus 5 7, 7 plus 11 12. Again 3 divides. 8 time, carry 1. 14, 3 divides 4 time, carry 2, 7 time. Again see 8 and 4 12, 12 and 7 12 and 7 19. So it does not divide. So which number divided? Let's see. So 3 does not divide. 5 also does not divide. 6 also does not divide. So it will divide it by 7. Yes, 7 divide here 12 time and here 1 time. And it is divisible by 11 time. No? Therefore 7623 is equal to 3 into 3 into 7 into 11 into 11. No? So for cubic number, all the factors should be present 3 times. No? If all the factors present 3 times, then it becomes a cubic number. But here see, there are 2 3s are there, 1 7 are there, and 2 11s are there. So to make it perfect square, we have to give 1 more 3, 2 more 7, and 1 more 11. That means, so the number, therefore 7623 must be multiplied by what number? See, 1 3 is less, so 3. Only 1 7 is present, that means 2 7 into here, right here, 3 into 1 2 7 less, 7 into 7, and 1 11 is less, 11. So with this number, if we multiply the given number, then it will become a perfect cubic number. No? Therefore 7623 must be multiplied by 3 into 7 into 7 into 11 to make it a cubic number. No? Cubic number. So these 2 questions were very easy. Let's go to next question, which is quite question number 11. Because those questions you can solve yourself, that is why I am doing question number 11, which is most important sum of this chapter. And one sum of this type always come in exam. Examine if the integers 701 and 1009 are prime or not. We have to check whether this number are prime or not, but we can check them using the factorization method. But here we have to use the theorem 12. No? What is theorem 12? Theorem 12 is that if n is a composite number which is greater than 1, no? N is a composite number, then n will have some factors. No? Among those factors, there will be a factor which is least factor. Suppose 20 has factors 1 2 4 5 and 20. No? So among these factors, except 1, there is a least factor. 1 more is there, 10. There is a least factor which is 2. No? The 2. So it means in this case 2 will be less than square root of 20. 2 will be less than square root of 20. Yes, it is obvious, because root over 20 means what? 4 point something. We will get 4 point something, which is like greater than 2, no? So if n is a integer composite number, n will have some factors. Among those factors, if q is the smallest factor, then q will be less than square root of n. This is the theorem 12. Huh? Suppose 6 is a number. 6 has factors 2 and 3 and 6. So among these factors, 2 is the least factor and 2 is less than square root of 6. So this is the theorem number 12. Using this theorem, we have to prove it. No? If n is a, again I am telling, if n is a composite number, n will have some factors. So among those factors, if there is a least factor always present, so if q is the least factor, then q will be less than square root of n. No? So we have to find using this method. No? So we have to find, examine whether the integers 701 and 1009 are prime or not. So I am doing one, you will do one yourself. So let, if p is the least factor among the all factors of 701, then what can you write? P is less than square root of 701. This thing we can write from the theorem number 12. No? So now we have to find the square root of 701. So try to find the square root of 701 now. How to find the square root of 701? By long division method. First of all, we have to pair these two. No? So this is one pair, this is one pair. No? So there are two pairs. So first of all, we have to, two pair means one digit is left, so it will consider this one bar. We give bar on the pair from left hand side, right hand side. So there are one pair and one digit is left, so here we have to give bar. That means the square root of this number is going to be a 2-digit number now, because 2 bar comes here. So first of all, we have to consider a number which is square, that means nearest square number of 7, because first digit is here 7. So nearest perfect square number is 4. So we have to give 2 here and 2 here. You know this thing, how to find the perfect square root of using long division method. I am not going to discuss it elaborately. So 2 into 2, 4. So 3. Now this pair will come down 3. And now we will put the double of the number here. No? What is the number here? 2. We have to put here double, that means 4. Now we have to put some number here, and we have to put that number here also, by which if we multiply the whole number, then it should be either equal to 301 or it should be less than 301. So what number should be it? So if we have to give 6 here, 6 and 6. So if we multiply 6 into 6, 36, carry 3, 6 into 4, 24, 24 and 3, 27. No? So now subtract here 5, 9 minus 7, 2. So 25 is the remainder. Now see, 701 do not have a perfect square, because the remainder is 25 here. No? Since the remainder is 25, so 26 is not the perfect square root of this number, no? But it will be 26 point something. That means Since the perfect square root of 701 is not 26, no, it's not exactly 26, therefore we can write root over 706 root over 706 root over 706 would be 26 point something, no, which is greater than 26. That means greater than 26. Root over 706 is greater than 26 because 26 point something we will get here, but less than what, 27, no? Because it is not exactly equal to 27, also not more than 27, but it is less than 27 because we got 27 point something square root. So that means root over 706 lies between 26 and 27, no? Now we will see all the prime numbers of this number less than 26. So you have to write now all the prime numbers less than 26 are, what are all the prime numbers? Sorry, it is 701, 2, 3, 5, 7, 11, 13, 17, 19, 23, no, and 25, not 25, no, 25 is a composite number. So less than 26, there are these are the prime numbers present less than 26, no? Now if 701 would be a composite number, then among this factor either of this number will divide 701, this number, no? But if we say all of this factor does not divide 706, no? 70 among from this all the factors, no factor divide no numbers divide 701. Why we are considering this number only? Because square root of 701 is greater than 26, no? So there is no number which is greater than 26 will divide, and 26 is not exactly divide 701, and more than 26 there is no number which will divide it, no? That is why we are considering the prime numbers. Why we are considering prime numbers? Because we know that a composite number is expressed as the product of prime numbers, no? So we are considering the prime numbers below 26. So if 701 would be a composite number, then it must be divisible by any one of the factors less than 26. But if you check one by one, 701 never will be divided by all this number, no? So you can write, but no prime number less than 26 divides 701. Therefore 701 is a prime number. So in this way you have to do the next sum, which is 1001. So for this is not so important exercise, that is why I have done less number of sums. But if you do any more sum from this exercise, I will solve for you. Otherwise I will proceed to the next exercise. Thank you.